Great, so welcome back to grade 7 math. We are now looking at 5.2, which is the relationship between parallelograms and triangles. So if we just do a quick review, the area of a parallelogram, what we learned, is the same as the area of a rectangle, which is base times height. And we have to just ensure that when we label the base and the height, the base is one of the side lengths. The height is the perpendicular distance from the two bases going at a 90-degree angle from the base going up. It is not one of the side lengths. As we looked in class, really, this is the same thing as a rectangle. If we were to just slide this over one of the bases, the height would stay the same, the bases would stay the same. So it has nothing to do with the side lengths, it has to do with the height. So what we can do then is we can then take this parallelogram and divide it into triangles. And it's pretty simple. We can ask ourselves how many triangles are in a parallelogram. And if I just do one simple cut here, I notice that there are two identical triangles in this one parallelogram. So therefore, the area of this triangle is going to be the area of the parallelogram divided by 2. So then this relationship turns into, if we start putting in the bases and heights, area of a triangle is equal to the area of parallelogram divided by 2, because there are two triangles in a parallelogram. I can replace the area of a parallelogram with the actual formula, base times height divided by 2. Gives me the area of a triangle. So let's just repeat that again. Area of a triangle equals the area of a parallelogram, which is base times height, divided by 2, because there are two triangles in each parallelogram. I could also rewrite this as base times height all over 2, or 1/2 times the base times the height as well. So if we give an example, let's say this parallelogram has a base of 5 centimeters and has a height of 4 centimeters. The question is, what is the area of this triangle? So if I put in the numbers in the appropriate place, the base is down here, so this is the base and this is 5 centimeters. Now the height is a little bit tricky to draw because this is the 90-degree angle from the base. So in order to do that, I go to the highest point and I drop a line all the way to my imaginary base. And so this height, or I could do it here as well, they're both the same. And this height is 4 centimeters. So the area of this triangle is equal to base times height divided by 2. Base is 5 centimeters times 4 centimeters divided by 2. I follow my rules of BEDMAS, so 5 times 4 is 20. Centimeters times centimeters is centimeters squared. That's the full parallelogram, would have been 20 centimeters squared, but then half of a parallelogram is a triangle, and that gives me the area of this triangle is 10 centimeters squared. So just as a recap, area of a parallelogram is base times height, but because there are two triangles in each of these parallelograms, I can do area of a parallelogram divided by 2 gives me the area of one of these triangles. We'll be doing a couple more examples in class with the actual measurements using rulers to see if we can find the areas of these triangles, and then we'll be working a little bit backwards. If we're given